The world consumes 6 billion tonnes of oil and gas each year. That's $3 trillion of fluids. This vast quantity of fluid flows from reservoirs all over the world. It flows from wells, process facilities, pipelines, tankers, refineries, downstream facilities, distribution networks, before it finally reaches the consumer.
But we have a problem. This, the world's most valuable supply chain, can be very difficult to manage. There are daily problems, gremlins, bottlenecks, interruptions, all along the value chain that disrupt the flow to markets. We can deliver so much more through the assets and infrastructure that we already have. Upstream, hydrocarbons are complex fluids, and reservoirs produce them in dynamic, heterogeneous mixtures. This creates a never-ending battle downstream of the reservoir to stabilise the flow, optimise the process facilities, and maximise the throughput. But this is much tougher than it ought to be. Measuring flow is expensive and intrusive. Different pipes, different fluids, different pressure and temperatures, these all require different types of flow meter technologies in different sizes and different pressure and temperature ratings, all with different performance characteristics and all supplied by different vendors with different calibration and lifecycle performances. This huge industry has grown up organically and iteratively over many decades, and now all over the world there are many different sensors, all feeding their readings into different various data pools. But the problem is this is human readable data. In the early years of Industry 4.0, it's already obvious that these human readable instruments and the human readable data are far from ideal for creating the best artificial intelligence. The world's existing flow sensors are all too slow, too fuzzy, and too different from one another to generate the best kind of data for creating the most intelligent AI. What we need is a universal standard sensor that works on any pipe size, any fluid, and any pressure and temperature, that generates data 1,000 or 1,000,000 times faster than any existing sensors. A universal instrument means a homogeneous data set, and that means we don't need to prepare the data before we feed it into the machine learning process. What that means is we can stream data directly from the field into the machine learning process to produce ever-improving algorithms, all in real time.
As fluids flow through a pipe, there are losses. Kinetic energy leaks out and excites the pipe wall. This phenomena has a deterministic relationship with the flow conditions inside the pipe. We use a laser beam to measure these microscopic vibrations millions of times per second with nanometer accuracy, and we train a neural network algorithm to understand these nanoscale vibrations in terms of the flow rates and the flow regimes inside the pipe.
Our problem is our relatively small lab with limited flow line capabilities. What we really need is access to a full-scale flow measurement facility so that we can harvest data that's much more representative of the kind of applications that we hope to see out in industry.